So now we are going to look at fuses. Like you already know, fuse is a very important component in the electrical system. So we are going to look at how they are represented in the electrical schematics. So as you can see on your screen, the fuse has an element, a fusing element in it. So how it functions is that once a certain load is carried, that fusing element will fuse over some time, okay, due to I square arrow effect. So it is basically for the protection of the circuitry. So that is why fuses are installed in the circuit and is installed in series with your load, which means that whatever current or load that is flowing through the circuitry will flow through the fuse. So that fusing element is made of resistive material or resistive material, okay? So the wire in the fusing element is made of resistive material. So this resistive material, once it carries load, because of the I square arrow effect, definitely heat will be generated. As this heat is generated, of course, it will get to a stage, it will cause the fusing of that element and, of course, opening the circuit. So how are they represented in the electrical diagram? So as you can see on your screen, that is how fuses are represented in the electrical diagram, okay? So whenever you see any symbol like this, you know clearly that what you are looking at is a fuse. So we also have other types of fuse, okay? As you can see on your screen, those are other types of fuse, and we have numerous types of fuse, but know the basic function of the fuse, which is to open the circuit on overload or on short circuits, okay? So you can go through our training on protective devices, fuses, circuit breakers, and what have you, okay? So when you go through that training, you will see that we have the fuse elements that are meant for the protection against overload, okay? The high breaking capacity fuses. We also have others that protect against short circuits and momentary overcurrent that may be caused by lightning or whatever voltage spikes that we have in the system, okay? So those ones are known as the high rupture capacity fuses. So check out that training, you will see those fuses and how they function to protect our circuitry. So if you look at the circuit diagram on the right, you'll see that we have 4 fuses, okay? One is in line with the power to the entire load, and then we have one to each of the load, circuit 1, circuit 2, and circuit 3. So as you can see, this shows us clearly that we have fuse 1, fuse 2, fuse 3, supplying or feeding circuit 1, circuit 2, and circuit 3. Then we have a fuse that is feeding the entire circuit, okay? So once we see this symbol, we know clearly that what we are looking at is the fuse. So next we are going to look at the circuit breaker. The circuit breaker is another very important component in the electrical circuit. You will agree with me. So the circuit breakers, like the fuse, its main function is to protect the circuit, in addition to switching on and switching off electricity or power supply to your circuit, which means the circuit breaker has two functions. It can function as a switch and also as a protective device. So it has some advantages over the fuse element or the fuse, because the fuse, once it fuses, you need to replace that fuse or replace the element. Okay, but in the case of the circuit breaker, all you need to do is to reset that circuit breaker by, once it trips, by switching it off and then on again. Okay, so with that, you'll be able to reuse the circuit breaker without removing the circuit breaker and replacing that particular circuit breaker. So we also have another training on circuit breakers. You can check that out. Different types of circuit breakers, the low voltage circuit breakers, medium and high voltage circuit breakers, the various types and how they function, the operating devices, okay, the operating mechanism, like the one you have on your screen now, has the thermal and the magnetic operating mechanism, okay? So how they function, you get to know all about that in that particular video. So you can check it out also. So as you see on the screen, that is how the circuit breaker is represented, okay, on the circuit diagram. So that's the symbol of the circuit breaker. So whenever you see such symbol, you know clearly that what you are looking at is a circuit breaker. So we have two types, the non-detachable and the detachable circuit breakers. Okay, so the non-detachable, you see that you have just a connection dot on two connection lines on both sides. Okay, that is the non-detachable circuit breaker. Then the one that have double arrows following each other on both sides of the circuit breaker tells you clearly that what you are looking at is a detachable circuit breaker. So like what you have here now, okay, you see this is a circuit breaker. This part is connected to your bus, okay, or your load, and then this part to the main bus, okay. So you see that this part is screwed to the bus, to the load bar, the load, let me say the load bus, not the main bus now, or the incoming bus. Are you getting it? Or the feeder, the load feeder. In bigger circuits, you can call them feeder pillars, okay? So it is screwed to it. So that means that for us to change this circuit breaker or work on this circuit breaker, we need to physically unscrew it and remove it from the circuit, okay? So if you look at that screen, that diagram in the middle of your screen, that shows how the circuit breaker is represented with the operating mechanism, okay? So what you are looking at is one with a thermal operating device, okay? So that's operates when it sees an overload for a sustained period of time, okay? Then we also have the magnetic operating mechanism, okay? As you well know, as the current flowing through a conductor increases, the magnetic field around that conductor also increases. So in the circuit breaker, it is designed to either pull, okay, the way a solenoid functions, either pull or push a plunger that will trip the circuit breaker, okay? So that is the operator, the operating mechanism of that circuit breaker. So if you see it like this, you know it is the one that have the magnetically operated, there is a magnetically operated circuit breaker. Why this one is a thermally operated circuit breaker. So like we said earlier, there are some circuit breakers that have a combination of both, like what we have here, have a combination of both the thermal and the magnetic operating mechanism. So such circuit breakers, they are represented like this. So with this, you know that that particular circuit breaker that you are looking at, okay, have both the thermal and the magnetic operator or operating mechanism. So you can also check out training on circuit breakers. That will give you more detail on how this operating mechanism functions and how you can utilize the function or the capability of this circuit breaker to better protect, that is the capability of circuit breakers like this to better protect your circuits. Okay? So this is a medium voltage circuit breaker, a detachable circuit breaker, because you see the circuit breaker could be racked out of the switch jar. It is usually in the middle of the switch jar, as you can see in the diagram on your right. Okay, so this is a detachable circuit breaker. That's why you could rack it out, medium voltage circuit breaker. So the three-phase circuit breakers, they are represented, as you can see on your screen in the left. So that's the three-phase. The first one is the non-detachable type, while the one under is the type that you can rack out, like this particular one. Okay. So we also have the detachable circuit breaker, as you can see in your screen. So this is the circuit breaker that you can remove from the switch jar housing. Okay, so we have both the detachable and the non-detachable circuit breakers.